I hereby open the meeting. Mr. Kang, I bid you welcome. You are appearing before a committee appointed by the Doctorate Board of Erasmus University Rotterdam to defend your thesis and the appended propositions. Before we start the discussion, I invite you to give a short introduction in which you tell us about the subject, aims of your studies and your findings.
Thank you. Dear Rector, dear colleagues, and dear friends, I'm very glad to give you a presentation today for my PhD research, using natural language processing to improve biomedical concept normalization and relation mining.
Could you bend the microphone a bit more to your mouth?
Okay, yes. Like this?
Yeah,
okay, great. One of the most important things for scientific researcher is reading papers. Normally, a scientific researcher can read 10 papers per week or 500 per year. And normally, they find the interesting papers either through PubMed, which is a collection of biomedical scientific papers, or through Google Scholar. But 500 papers per year is not enough, because PubMed has more than 1 paper per minute, and PubMed is only one resource for scientific papers, and there are many other resources are available. So this is called information overload. And by using the search engine to find the interesting information, there are a lot of limitations. First of all, when you input a keyword through the search engine, and the search engine returns a list of results, interesting papers, you still need to read a lot. You need to click the link and go through the papers, read the abstract, or through the chapters. Also, it gives irrelevant information. For instance, for the keyword of PSA, it has several meanings in different fields. And even in the biomedical field, it also has hundreds of meanings, such as gene or protein. And if you input only one keyword, it will return you a lot of results. And if you input several keywords, you will lose a lot of information. So, to solve the problem of information overload, we need to translate the human readable language into the computer readable language by using natural language processing and information extraction. But this is not an easy task. Normally, for communication, it is important to understand the language rules. And if you don't understand the language rules, you will make a lot of mistakes and even make things more complex. For instance, this is a small text written in Chinese. And if you want to understand this Chinese, you need to know the grammar and you need to know the meaning of those words. And if you don't know anything, then it doesn't make any sense to you. For the computer, it's the same. To make the computer understand people's human language, there are several steps. First of all, you need to do the syntactic analysis, which include sentence splitting, tokenization, part of speech, and chunking. This is an example of the chunking annotation. We can see the green part is a noun phrase, and the red part is a verb phrase. After the syntactic analysis, it's a named entity recognition. We can see here is an annotation of a drug and a disease. After that, you can do some more steps like concept normalization and relation mining. Concept normalization is trying to give the interesting term a database ID, and based on the database ID, you can find more information of this concept. And for the relation mining, is trying to get the relation between different concepts. So the aim of this research is trying to explore new ways for the concept normalization and relation mining by including natural language processing and the knowledge base. It also investigates the impact of that strategy on the current text mining pipeline and evaluates the result of that strategy. Also, it provides a large set of entity text for improving text mining systems. Because of time limitation, here I only introduce two of the research topics I did. The first one is ensemble approach. Ensemble approach is trying to combine the strings of different systems into a single combined system. For instance, here is an example by using the voting scheme with threshold of 3. We can see the system 1, system 3, and system 6 has the same annotation, so it becomes the combined result. Here, the threshold of 3 means that at least 3 systems have the same annotation, then it can become the combined result. We applied our ensemble approach to evaluate the performance. In the text mining domain, we use a position, recall, and F-score. Position refers to the accuracy of the system annotation, and recall refers to the coverage of the annotation, and the F-score refers to the combination of position and recall. Here we can see on the left side, the gold standard annotation, there are two annotations. The gold standard is from the human being, and the system annotation is from the computer. For the first one, we can see it only annotates one annotation, which is the same as the gold standard. So the position is 100% correct. But the recall is only 50% correct because it missed one annotation. And for the last one, besides the two correct annotations, the system also annotated 3 mistakes. So the position is only 40%. But because it annotated all the correct annotations from the gold standard, so the recall is 100. Only for the second one, which is exactly the same as the gold standard, and it becomes perfect for the F-score. And the F-score is between 0 and 100 percentage point. And the bigger the number, and the better the performance. We evaluated our ensemble approach into the 2010 I2B2 challenge. I2B2 challenge is for concept annotation of clinical records. And our combined result is 5% better than the best single system. And we found that even the worst system also contributes to the performance. And we ranked the top 3 among 21 teams all over the world. Besides of these advantages, we can also play with voting threshold. Here we can see when voting number is 1, which means that if any system makes an annotation, we mark it as a combined annotation. In this situation, then the recall becomes very high, but the position becomes very low. And when voting number becomes 6, then the position becomes very high, but the recall becomes very low. And when voting number becomes 2, we can get the highest F-score. So by using the voting threshold, we can play with position and recall to meet different requirements. For instance, if we want to make the annotation of the drug side effect, we want to make a very high position, then we can change the voting number to a big number to meet this requirement. We also investigate the relation mining of drug and adverse effect by using the ADE corpus. ADE corpus is a collection, includes around 1,700 PubMed abstract and 7,000 relations. And we use natural language processing and knowledge base. Natural language processing is a rule-based system which including a lot of rules to improve the syntactic analysis. And the knowledge base is a collection of different concepts and relations. Here we can see this chart shows a lot of different kinds of concepts and their relationships. For example, for the disease and the drug, although there are a lot of concepts in between, we can still find the relationships between them. And for the result, we can see that for the baseline, which is a dictionary-based system, plus a co-occurrence of different concepts for the relations, the baseline is only 16% for the F-score. And by adding the NLP module, it becomes a 33%. And after adding the knowledge base for the relations, it becomes a 50%, which is a big improvement. Also, compared with the machine learning-based approach, it has several advantages. For instance, our approach does not need a training set, and it's easy to apply in multiple domains. Based on my introduction, we can make the following conclusion. Ensemble and knowledge-based approach improve concept recognition and relation mining. Also, this approach offers advantages in terms of simplicity and dealing with sparse training data. So finally, with the power of text mining, we can enjoy our life with family and friends and leave the mess to text mining. Thank you for your attention.
Thank you for your presentation. I now call upon Professor van der Leyen, you promoted, to start the discussion.
Dear candidate, first, my congratulations.
Thank you.
You've made the end of this journey, and certainly it wasn't the first big journey in your life. Given the number of people in the committee and the time available for to ask you questions, I would refrain from asking any questions, and we'll speak later.
Thank you.
Thank you. So your first real opponent is Professor Udo Hahn, Professor for Computational Linguistics and Language Technology at the Department of Linguistics at the University of Jena in Germany.
Dear candidate, when we write up PhD theses, we try to increase the state of knowledge in our field. And in your work, I saw lots of different streams of work and lots of data, so it's very content-rich. But I want to challenge you, could you describe for me the 2 or 3 really most significant contributions of your thesis, and not just name them, but argue why they are really new and extending our field?
A highly learned opponent, that's a very good question. I think, of course, I developed, I researched several approaches. I think some of them are quite interesting. One of them is a knowledge-based approach, which I already showed in my slides. It's a collection of different kinds of concepts and relationships, which you can use it for the relation mining and to find a different kind of relationship. Even there, you cannot find the direct relationship. You can still find from the map of the potential relationship of them. That's an interesting one.
May I just interrupt you? So this is a very nice point. Let's talk about this. So other people have also tried to use knowledge-based approaches.
Yes.
And my question really targets this particular extra that you have created. And if I would have to write a textbook on text mining, and I wanted to integrate your insights, so what should I attribute to you which has not been done by others? That is the real serious part of this question.
Yeah. Okay. That's a very good question. Actually, of course, different people use the different strategy, and the knowledge-based module also researched by previous researchers in different field. But we think in the biomedical field, this is still a new approach. We already tested and compared it with traditional machine learning-based approach. Those kind of work are not done before by the others.
Okay, so the second contribution?
The second contribution,
Major contribution.
I think it's I did not mention it here in my presentation. It's silver standard corpus, which I also developed. The silver standard corpus is creation of different system. So compared with a gold standard corpus, it's automatically created. So it's new and it's easy created and it's cheap. The reason I said cheap is because if you want to create a gold standard corpus, a lot of people need to be involved for the annotation, so which is very expensive. But for the silver standard corpus, because it's automatically created by the computer system, so it's cheap and easy.
Again, let me try to be more precise. The silver standard corpus idea has been developed in a consortium of researchers. So if you mentioned that this is a major contribution from you, so what is the major contribution besides the work that has been done by the consortium?
One topic we did is that we used the silver standard corpus to retrain the different system and doing a loop of the system so that it can further improve the performance.
Okay, so and is there a third one, or do you want to leave it with that, with these two remarks, knowledge-based approaches and silver standard corpora?
That's it.
That's it, okay. So then let me turn to one issue that might also be interesting for the audience here as well. You mentioned the ensemble-based approaches.
Yes.
And they are characterized by something, by property that is quite of unexpected, because in an ensemble actually beats even the best systems, including the work of not so good systems. So this is an observation. Can you try to explain why this is the case? Why an ensemble outperforms the best or even the top 2 or 3 systems in an ensemble?
So you mean why the ensemble approach can get higher performance than the best single systems?
Yes, we observe this property, but the question is, what are the reasons for this behavior?
I think the reason is because for the ensemble approach, it's a collection of different systems. So based on the different system annotation, by using a voting scheme, it can automatically get rid of the wrong annotations. That's the reason why it can compete the best single system. Actually, even for the best single system, it also makes mistakes. And by using a voting scheme, you can combine different strategies of the different systems, different features of different systems, and get rid of the mistakes of the different systems. It's just like our human society. If you bring all the powerful of different humans, you can build a lot of powerful things, great things.
Why is it the case that even the worst performing systems in an ensemble actually overall contribute to the better performance of the ensemble? This is even more contradictory to common sense, because they are bad performers, really very bad performers, and even when we integrate that contribution, the ensemble gets better.
Yes, actually, I believe if one system exists, then it must have some strengths. Although the performance of the worst system is not good, but it still have some annotations which are attractive and cannot be annotated by the others. So for the ensemble approach, it can filter the those kind of advantages of the world system. That's the reason why the world system also contribute.
Okay. Rounding up, you mentioned in your presentation that there is a perfect system which has 100% recall, 100% precision, and 100% F-score. This is really wonderful. Can you explain why this never happens? Why don't we get such a super perfect system? What are the reasons for that?
Yes, actually, what I mentioned, the perfect system is just an example. And based on my knowledge, I never see a system which can get 100% performance. This is actually, I think, this is just like the programming. Even one code of the programming language, it is not perfect. And in the field of text mining, there's still a long way to go. That's the reason why there's no perfect system. But we will try to make it the better.
Let me be a bit more concrete. I mean, the reason why we don't get these systems is something that we observed, particularly in the document retrieval area. Do you know about the relationship between precision and recall, and what could be the reason for my question?
The relationship between
So in document retrieval, we have an almost natural law, which is very unusual in empirical sciences. And there's a trade-off between precision and recall, which means actually if you get high precision, you get low recall, inevitably. And when you want to achieve high recall, you get very low precision. And then, of course, F-score somewhere hangs around 50% or so. So this is kind of an empirical law. Why is this the case?
Okay, I got it. Actually, the position is evaluate the accuracy of the system annotation, and the recall is evaluate the coverage of the annotation. So if you want to make it more accurate, then you need to make more annotations. Then it will always make mistakes. Then the recall will become low. And in the other way around, if you don't want to miss any annotation, then you could make more mistakes which impact the position. That's the reason why if recall is high, normally the position will be low. Also the other way around.
Okay, in the interest of time, thank you so much. This concludes my question round.
Thank you.
Thank you very much. The next opponent is Professor Mons. Professor Mons is Professor of Biosemantics at the University of Leiden.
Thank you, Doctor. Your candidate. You can relax a little bit now because I won't ask any deep technical questions, also to not expose my little knowledge there. But what I will do is ask you a few questions about the boundaries of your research in the future and where the limits of text mining are. So the first question is about the future of research where we create, especially in the life sciences, enormous amounts of data via high throughput. And my first statement would be that 99% of those associations that we find will never make it to text initially. They are published in supplementary data and tables that are unreadable. So if it is true that text mining, especially in the future, will only capture like 2% of what we make explicit in other forms than narrative English language, you know, what's the point of making that 2% completely perfect? So let's assume you have the perfect tagger that we will never get, and it recognizes every concept in every text perfectly okay, and you would still only cover 2% of the knowledge. Do you see any way to use your pipelines in the future for other than narrative sources?
So, a highly rated opponent, thank you for your question. So your question is how can I use those 2% perfect data annotations to make the annotation of our 98% of the data? Mm-hmm. Okay, that's a very good question. Actually, I think by using those 2% annotation, by using, for example, using the traditional machine learning-based approach or using the ensemble-based approach, we can, using this 2% data to train the system to apply them in the rest of the data to check the performance. And then we can apply other approach like the knowledge base and so on to further improve the performance and find new knowledge or information from the rest of the data.
So, can you comment on the fact that you use, among other things, the knowledge base for disambiguation of ambiguous terms in narrative because you have a context around it? But now, if we have some shocking results recently from the genetics field, where it appears that the mutations and the diseases that we know, if you go in PubMed, you find about 2% of them by text mining. You go to full text, you expect a lot more, you only find 4%. And it appears that the rest is in tables that are frequently TIFF files and not readable, or in supplementary data in some relational database somewhere. Even if you get there, the context of narrative is gone. So how do you see the balance between the fact that you don't have the context and the narrative around it versus, you know, in a relational database, this column contains genes, so it's much easier to disambiguate the terms. So do you see that your pipeline can be easily extended to this kind of data?
Yeah, currently what I'm working on is only for the unstructured data. So if we want to explore something in the database, which is structured data, then we think we need to develop some interface and try to solve some potential problem which exists in the database.
Okay. So then I have another question, which is the very other end of the spectrum of this. I was reading your thesis and the articles that came out before, and I get really almost a bit upset, not with you, but with the idea of perfect text mining. Because just for fun, I took your own example, BDP and GVHD, that you put in your thesis, and you go through all these steps to perfectly recognize that one statement. And I typed those two concepts in Google yesterday night, and I got 17,700 hits for the co-occurrence. So text mining is not a goal in itself. It is really there to support knowledge discovery, okay? And is it not so that most of the statements we need to do knowledge discovery, to build these networks, will be found somewhere in a very non-ambiguous, easy way? You find them 3 times. What's the point of finding the other 17,000 perfectly? And how can we make a pipeline that is optimized for knowledge discovery instead of finding the last statement that has been done thousands of times already?
Well, I think to do this work in the current stage is still impossible, but we can try to using different approaches and make the system more optimized for extracting the data, but there is still a long way to go.
Well, I think there is a very nice way of exploiting your knowledge base to avoid remining of things that are already so well established. You can just, at some point, start to ignore them in further text mining and really optimize your systems for finding new things rather than well-established things.
Yeah.
So that is one thing. I'm looking at the rector whether I have still a little bit of time or not.
Yes.
Then I would like to really challenge you on one of your statements, number 7. You say that the number of papers that a scientist produces is one of the most important measures for scientific productivity. I would like to challenge that very much, because I think that, especially in the future, the number of papers is totally unimportant. It's the amount of new data and new insights you contribute to the community. And that's very little relationship with the number of papers, so maybe you can comment on that.
I don't agree with you, because until now, the way to evaluate the work of the scientific researcher is still the number of the papers and the quality of the papers.
So are you just stating the status quo there? That's unfortunately the case. Or do you agree with that way of looking at researchers?
Yeah, of course, looking at researchers, it is very important to discover new knowledge and new data. But how you let the community or the world know what you have done?
Okay.
That's the-
Well, we can discuss this over beers later, but in the interest of time, I give the word back to the rector.
Thank you very much. The next opponent is Professor Vos. Professor Vos is Professor Theory of Health Sciences at the School of Care and Public Health Research in Maastricht.
Thank you, Mr. Rector. Dear candidate, congratulations with your book. I very much liked the front page with this sort of blowing the spirit in the world. But I think there's a lot of engineering and hard work underneath it. I would like to ask you a question about chapter 6, the knowledge base. Perhaps you can also put the slide on. I like that slide, the slide which you had on the knowledge base. Is that possible?
I think so. Let's see.
If it is too much trouble.
You mean?
Yeah, this one, yeah. Then as the audience can also looking at it, at this enormous cloud, so to speak, the knowledge base, I would like to ask you a question about the table 3 at page 114. There you are, in this chapter you are using the knowledge base and see whether it helps improve the results, the performance on extracting adverse drug events. And in this table, you see that the knowledge, by using the knowledge base, you really improve the system, okay? But you say that there are different thresholds. And as I understand from you, thresholds are, so to speak, the paths you are traveling around through this cloud. So
Yes.
that's correct, huh?
Yeah, yeah.
Right. So there are 1, 2, 3, 4, 5 thresholds. And so that means that each threshold means a step in this enormous cloud.
Yes.
Now, what I want to show, to emphasize here is that in terms of your recall, with threshold 2, there is 15.2%. And with threshold 3, it increases enormously to 64.1%. And then again, with the fourth to 74.8%. And the F-score is really dramatically increasing as well.
Yes.
It's amazing, isn't it? At least, you see I have some problem with my glasses, but that's an engineering problem as well. My first question is actually, I mean, this increase, it's quite impressive, I must say. Do you have some explanations about what is happening here? I mean, when you go from, let's say, 1 step to 2 step to 3 step to 4 step, that somehow it generates an enormous increase and then at some point it levels off. Do you have some ideas about this? And I'm particularly interested in your answer because throughout your thesis you are actually making your point that it's not only by making the text mining pipeline, but that a very important issue is of making use of available knowledge in science and in text mining, and actually using the knowledge base is a way of saying we are reusing and using available knowledge, so to speak. So I would also be interested in, first, your explanation, and second, can you give some sort of elaboration how you think as an engineer for taking further use of the knowledge base in your work? And as I understand, you are a man of short answers. I will first wait and see, and then at the end of your answer, I will offer you €1 million and see whether I can press you again for further answers.
Highly learned opponent, thank you very much for your very interesting questions. First of all, I will explain the tables I showed in my thesis. Actually, in this table, from the threshold 1 to 5, And especially from threshold 2 to 3, the recall is and F-score is dramatically increased. I think the reason is because when you increase the threshold from 2 to 3, it's not like just the number increased by 1. It's like it increased the path a lot, which will cover a lot of potential relationship between concepts. That's the reason why the recall and the F-score increased a lot. And regarding to your second question, how can I use a knowledge base? Actually, this is also one of the future works, because currently the knowledge base is only including the UMLS database. UMLS database is a collection of the concept and relationships. And we would like to extend it by including some other database to make it more powerful and to make it including more concept and relationships, so that in the future it could get more performance.
But still, you were quite rapid in terms of your explanation. I mean, were you actually surprised when you saw? I mean, you must have been at some point looking at your screen, your computer screen, and see the figures. Were you surprised, or did you just expect it?
Yeah, I think I'm not that surprised, because I already did a lot of research by using this, changing the threshold of different system or different knowledge, different database. And I assume when you increase the threshold, it must be increase the performance. But in a certain level, it will also decrease the performance if you always increase the threshold number.
But how would you then see further improvement by using the knowledge base? I mean, there is a leveling off. You have already, so to speak, achieved then all the success of using the knowledge base. How would you then see further improvement?
To get it further improved, as I said, we need to include more database.
So you expand it, so to speak, more information.
Exactly.
All right. Okay. Yeah. But if I would give you now an offer, I mean, would you like to have €1 million for further research?
Yeah, of course. I like to do the research. But
would you be very enthusiastic about it, for getting that money for research?
yes.
Yes.
Not,
Okay.
of course, but I already got a job, so.
What would you do right now? I mean, what would you do now for giving this result? Because you are expanding a little bit in terms of the discussion, but really in terms of what would you really address now for using the knowledge base in this context?
Okay, if I get a lot of money, I will hire a lot of people and I will be a boss and let the people do the stuff. Okay, this is just a joke. If I get a lot of money to do those kind of research, first of all, I think I need to expand the knowledge base, because the power of the knowledge base is trying to use existing knowledge. Yeah. And actually in the scientific field, a lot of people in different countries always do the repeated works, and it will waste a lot of money and a lot of energy. If we can avoid this kind of repeat work, then it's amazing.
Okay, I understand. I think that's okay. Thank you very much.
Are you going to pass the money now? Or?
I don't have it, actually.
The next opponent is Professor Jenster. Professor Jenster, Professor of Experimental Urological Oncology at the Erasmus MC in Rotterdam.
Dank u, meneer de rector. Dear Mr. Candidate, I also would like to congratulate you on the work performed for this thesis.
Thank you.
And I really enjoy the clarity of your story. And even a simple mind like me as a molecular biologist can actually follow the different steps that you take, which I think is quite amazing to do. I would also like to congratulate your promoter and your two co-promoters with this work. What I would like to do is go to proposition number 10, and it would be fun if maybe one of the paraninfo would actually read that out loud. Proposition 10.
So proposition 10 actually states, by using an advanced machine learning algorithm, it is possible to predict stock prices. Thank you.
Well, I really hope this is true, by the way. That's one thing, and I hope I have that learning algorithm soon in my hands. That would be fantastic. It's the only one in the world. But there's two important things missing in this proposition. And that is the time frame of your predictions and your precision in your prediction. Could you, with this proposition, tell me in which time frame were you thinking of?
Highly learned opponent, thank you very much for your questions. Actually, for this proposition, I think the time will be quite long because for the stock market, it's not extremely difficult to predict the stock price. But I believe by using the advanced machine learning algorithm, here I used advanced, which means that you need to use a lot of data to train it, or using some other strategy to make the system more smart and to meet different situations, so to make it more accurate to predict.
Yes, but there's the basis of the system. Do you know what the basis of the system is in the stock market? Is that a linear system, a non-linear system? Is it chaotic in origin?
I think it's non-linear system.
It's a I fully agree. And one of the definitions by a non-linear system depends on how non-linear it is or how chaotic it is. It severely affects what is happening and how much you can predict. And if I would then go for the weather, do you think, and there would be eventually an advanced machine learning algorithm, as you mention it and you call it, to predict the weather in a month from now, in the Netherlands, by the way. I think in the Sahara Desert I can do it as well, but now in the Netherlands, do you think that that is possible or not? Predict the weather in the Netherlands?
That's a very good question. Actually, my father and my mother also work for the weather prediction. So I know this a little bit. Actually, my father are doing the long-term prediction of the weather. And it indeed can be, the weather can be predicted for a long term, for example, like 1 month. But the performance is not that high.
Yes, that's also what I mean. I can predict a month from now, but I can tell you the chances I'm wrong is extremely high. I'm afraid I don't fully agree with proposition number 10. I think it is, by the way, because of its non-linearity, impossible to predict. There's a second part to it, that if you can predict it, then you would buy stocks at a certain price, therefore you change the stock market, and therefore your prediction goes wrong. So there's also an observer effect that is part of the game.
Sorry, this one actually I don't agree with you, because actually for my proposition 10, your assumption is correct, but it will never become true. Actually, you add another assumptions on my proposition, which is if we can use an advanced machine learning algorithm to predict the stock market, and if all the people want to use it, then I agree the stock market will be changed by person behavior, but it will never become true. It's just like you assume that if all men go to the temple and become a monk, then the human being will extinct. That's not impossible.
That's right. We call that, it's kind of an active observer phenomenon. As you know, it's in physics a big issue. But it does play a role, I think, in your proposition. So I think we still disagree on this part. I would like to now go at least to one fraction of your thesis and have another discussion, if you don't mind. If you could go to page number 99, this is chapter 5, table 1. And let me quickly explain what you have done there. You've used two algorithms, MetaMap and Peregrine, to use on a gold standard corpus to find out how well they can actually extract and annotate specific concepts. And you get a certain F score, obviously, then you add NLP and you get an increase in your F score, which is fantastic. Now, if you go to the errors you find, which is page 99, then if I read through that, I think, you know, I can see all the errors, and I think I can do this better. So if you go back to table number 1 on page 98, if you would take a human and would go through this corpus, what will be the F-score of a human being doing this, instead of the 2 programs that you mention here?
Thank you for your question. It depends on which person you choose to make the annotation, I believe.
I agree. So it would be me, and I have a little bit of knowledge about, you know, mesh and other terms, particularly diseases. That's going to be okay, I guess. What do you think will be the F-score?
Well, I think maybe you can get a little bit better than the system, but actually the system still need to improve. And someone already did some research work of the text mining field to compare a system with a human, and the computer system win.
Yeah, I think, by the way, it's a ridiculous question I asked, to be honest, but I think there might be a role, and that's my question. Without, you know, you have all these algorithms, that's what you do alone, but do you think within the algorithms, is there a use for humans on top of the algorithms or combined with the algorithms that might improve any system that is present in any part of your thesis? Do you think the human still has an important role?
Yes, I think so, because currently the text mining system are still not perfect. And if you first, actually a lot of people already did that before, which is let the system make the annotation first, and then let the human being to improve the result.
Thank you very much. I'd like to give the word back to the rector.
Thank you very much. The next opponent is Dr. Hazelzet. Dr. Hazelzet is Associate Professor of Pediatrics and Chief Medical Information Officer at Erasmus MC in Rotterdam.
Dear candidate, first of all, I would like to congratulate you with this thesis, and my congratulations also to your promoter and both your co-promoters. And I would like to start by saying that I'm very impressed with your study and with your booklet, and also the outside of the booklet, not because of the Dutch orange color, but because of the fact that it also has graphic symbols, and I think that graphic symbols are very important irrespective of any language, and very interesting in relation to information to patients. But the content is more about natural language processing, and your natural language is completely different from English and Dutch. That makes, I think, it's very, at least intriguing, but probably also difficult for you to have to do these kind of studies. And to stress this, I would like to ask you to read out proposition number 11. I don't think I can ask your assistant to do this. You need to do it yourself, probably.
So should I read it in Chinese?
Yes.
风来疏竹，风过而竹不留声；雁过寒潭，雁去而潭不留影。故君子之事来心始现，事去而心随空。Thank you.
You're right. Okay.
Shall we ask
Okay.
the audience whether it is correct?
Okay, my question is natural language processing ready for prime time? And with prime time, I mean the electronic medical record. Perhaps you know that in this hospital we are on the eve of signing a contract with a commercial company to buy a real commercial electronic medical record. And there are two important phases. One is to migrate all the information which is still in existing databases. The majority of the information is in narrative. And we are in the phase of configuring the new medical record. How can natural language processing play a role in first migrating old information to the new database? And second, how are we going to use, or should we take into account, natural language processing for the configuration of the new EMR? And then is the balance between narrative and structured text.
Very learned opponent, thank you very much for your question. Actually, I already did some research for the clinical record, and we attend the 2010 I2B2 challenge with also an annotation of interesting concept from the clinical record, and the result is quite good. And regarding to your question, first of all, I think we can using the natural language processing to first merge the different database by finding an interesting concept and put them into a specific column in the database, and then we can merge it. In the next step, we can try to find some interesting concept in the clinical record or the relations between different concepts. But of course, compared with text mining in the scientific paper, it's much more difficult because first of all, for the clinical record, there are a lot of grammar errors and a lot of abbreviations, wrong sentence, whatever. So it makes even more complex than analysis for the scientific paper, which is very well written. So there's still a long way to go, but we can still combine different strategies like natural language processing, knowledge base to do this kind of work.
Okay, especially in the migration phase, the precision is very important. Because then you are one-to-one migrate information from the old database to the new database, yeah, which is then the truth. When you read, for instance, HIV positive and you read HIP positive, that's something completely different. So not all the errors are the same, I think.
Yes.
Could you elaborate 1 minute on the impact of an error? Because not every error is the same.
Yeah, that's true. Actually, if you want to increase the position, we can use ensemble approach and change the voting number to a very high number. Then it can get a very high position. And of course, error can also contribute to the system because you can write some rules or train them. Then makes a system avoid those kind of mistakes again.
Okay, thank you very much.
Thank you.
Thank you very much. The next opponent is Professor Sturkenboom. Professor Sturkenboom is Professor of Analysis of Observational Data at the Department of Medical Informatics at Erasmus University.
Thank you. Dear Mr. Candidate, thank you for the invitation to discuss your thesis here with you. And of course, I'm not a biosemantics expert nor a text miner, but I'm actually a user of what you are trying to develop. So I'm very interested, in, especially in the last piece of your thesis, where I was looking at the knowledge-based extraction of adverse drug events from biomedical text. Now, as a pharmacoepidemiologist, what we try to do often is using clinical records and then try to assess associations between a drug and an event. And this caught my eye, actually, because you're trying to do the same thing in this. And you take a text mining approach. And so when I look at your recall and precision, it's probably better than many of the pharmacoepidemiological studies will do. So I thought this could be promising. Then when I started looking at it, I thought like, well, maybe what is actually being done here? Because you use a knowledge base, which is based on the ADE corpus. And the question is whether that ADE corpus is actually representing the reality of where you would like to assess the association between a drug and an event. Let me try to explain that better. The ADE corpus, as I understood it from your thesis, is being constructed by looking at case reports. Is
yes,
that right?
That's correct.
Do you know what a case report is?
The case report is some kind of a report based on the clinical record case, I think.
Yeah, case report usually from the literature is where there is a clinician that is recognizing the association between a drug and an outcome. So it's very unidirectional, I would say. It's describing that this drug is actually causing that event. So my question then was like, is that fair to then have a corpus on that and then look how many abstracts you actually need? Because there's only one direction.
Highly learned opponent, thank you very much for your question. Yes, I agree with you that our research is based on the corpus, which is selecting some specific associations from the clinical report. And I also mentioned in my thesis that for the real situation, the performance could be lower than what we tested.
Can I take you further there? Because, okay, so we agree that in the case reports, there is always like a positive association. Drug is causing event. If you would apply this to the literature, how would you think that your system would be performing? Like just not going to the case reports, but just looking at any type of paper.
I think the performance will be a bit decreased, but it will not decrease a lot, because our knowledge base is developed not only for the drug and adverse effect, but it covers more concept and more relations.
Can you elaborate a little bit on the type of relations that you're seeing?
All kinds of relations. It could be, for example, the relations between gene and protein, the relations between the drug and the side effect, the relations between the disease and gene protein, those kind of.
Okay, so you would be able also to pick up preventive or positive or beneficial associations.
Yes.
Is that what the system is trained for?
I think it depends on how exactly the document or you want to test it on the system.
Okay, so maybe if I have time to just one more question then is like, well, I started out while reading your thesis is that you would like to use this on clinical records, and the previous
yes.
was also stating about that. So what should we have to do? What do we need to do actually to be able to use that system? Like what is missing? You've now trained this. I mean, what would you recommend us to do to look whether this is actually performing better than the epidemiological methods that we actually are using to assess associations?
That's a good question. Actually, it depends on which kind of aim you want to achieve. If you want to find some other concept instead of drug and adverse effect, maybe there you need to make some tunings of the system. But if, of course, the system cannot cover all the situations, and you always need to make some tunings based on the result of the system and make the performance better.
Okay, I'll leave it here. Thank you.
Thank you.
Give the word back to the director.
Thank you very much. The next opponent will be one of your co-promoters, and I think it will be a turbo question because there's a little time. You are his co-promoter, associate professor at the Department of Medical Informatics.
Dear candidates, congratulations with your booklet. We've had many discussions, sometimes very detailed in the past couple of years. So I won't bother you with very detailed questions. But instead I was triggered by the cover and the icons on the cover. I didn't recognize them all, but some refer to social media, I think.
Yes.
And that's interesting because the mining of social media is currently a hot topic. One of the items certainly is mining of patient-reported adverse drug reactions, as you may know. So my question would be, if you think about your pipeline, where would you see the difficulties when you were to mine adverse drug reactions from social media? And maybe in particular, would you think your methods would still perform if you apply them to such data?
Hi, Lin and the supervisor. Thank you very much for your very interesting questions. Yes, to mining the social media is quite an interesting topic.
Mr. Candidate, the time allowed for the defense of your thesis is over. The committee will now withdraw to deliberate. Would you please wait here until we return. I adjourn the meeting. I reopen the meeting. Mr. Candidate, the Doctorate Board of Erasmus University in Rotterdam, represented by me, has considered your thesis. Having heard your defense and the advice of this committee, I grant you the title of Doctor. I authorize Professor van der Leij to bestow this degree upon you in the customary manner.
It is with great pleasure that I undertake the task Director Magnificus has allotted me by the authority invested by law, and according to the decision of the Doctorate Board of this university, I hereby confer upon you, Ning Kang, the doctorate degree. As a testimony and proof thereof, I present you the diploma signed by Director Magnificus, promoter, co-promoters, and other members of this committee, and endorsed with the seal of the university.
Be seated.
Having performed this task, may I take the opportunity to be the first to address you as a doctor and congratulate you on your achievement. For the laudatio, I will hand over the word to the co-promoter, Erik van Mulligen.
Is it working? Yeah. Dear Dr. King, it is my pleasure that I'm now the second one to congratulate you with your doctor. Congratulations with your achievement. This is the result of hard work. Hard work since your project involved the development of software methods and the evaluation of these methods. For the evaluation, you often had to create the datasets against which your methods were evaluated. And all we witnessed the result of this effort. When preparing this laudatio, I went through the first emails that we exchanged. Initially, the plan was to hire a software engineer for the Kelbic project. You reflected, but immediately asked whether we were open to change this position into a PhD position. And I remember very well the first interview we had. Jan Kors and Professor Johan van der Leij were present, where you led us through a large number of slides to show us how the indexing pipeline we developed could be improved. I was impressed by your analysis, although I had a different opinion about the whole refactoring and about the way you presented it. We decided to change the software engineering position into a PhD position and offered you that position. You spent long days at the university working on new methods and repeating many times the experiments to obtain results that could be published in the top journals in our field. And even more time you had to spend on writing papers that describe the results you obtained in a clear way. And I can imagine that you sometimes felt terrible after yet a revision that Jan and I criticized. But the final result is here, a booklet with 5 papers in high-quality journals. And I don't think that many people know, but you are co-author on the famous initial sequencing and analysis of the human genome paper, Nature 2001 article, as part of your work in the Beijing Genomics Center. When I was going through the emails, I found that out, and I almost forgot about that. During our trip together to the United States, to the EMIA conference, I got to know you better. The trip offered us the possibility to talk more on a personal level and on things not so much related to work. I remember that we ended up in an Irish pub, Murphy's, close to the Sheraton, where we were enjoying some Irish beers and had a long and nice discussion about what really matters in life. At that time, we didn't know what would happen in your life. On September 2011, we heard that your wife suddenly died. And I still remember how devastated you were at the funeral. Despite the grief and the pain of losing her, you continued to work and managed to get a grip on your life again. To be there again for your kids. And I don't think that many people understand in the audience how much strength that costs and how much strength that requires. Your will to pursue your goals is immense. Kang, you have been a great student and colleague, and you demonstrated to us that giving up is not an option. Long days of work and accepting each time the fact that we always had a last comment on your papers didn't hold you off. You will now continue in the scientific publishing field, but from the commercial perspective. I hope that you have learned to have a critical view and that you will be challenged in your new job as well. And you know our credo, never be satisfied with any easy answers. I hope and I'm convinced that our roads will cross again somewhere. All the best.
Dr. Kang, I have the pleasure also on behalf of the doctorate board of the university to congratulate you on having obtained your doctorate degree. I formally declare this meeting for closed now.